Yeah, hello everybody. I welcome you to Learner's Corner today. So today we'll be talking of kinetic theory of matter. Kinetic theory of matter. So kinetic theory of matter is trying to explain that matter has particles, and these particles are in constant motion. And because of these particles are in constant motion, they possess kinetic energy. That's what kinetic theory of matter is trying to explain. So I'm going to explain what matter is. Matter is anything that has mass and occupies space. Anything that has mass and occupies space. For example, now at your home you have a seat, you have table, you have chairs. All those things are matter. Even the air that is in your people house, the air we breathe, they are all matters because of what they are occupying spaces. So anything that has mass and occupies space is what is considered to be a matter. So for O level, matter exists in three states. Matter exists in three states. We have the solid state of matter, we have the liquid state of matter, and we have gaseous state of matter. I want to tell you that these three states of matter has distinctive features. They have things that make them not to be the same. They have things that make them different. You understand? So for the solid state of matter, the particles are held firmly by strong cohesive force. The particles are held firmly by strong cohesive force, and this force makes them not to move. For example, we know solid. The solid has a what? A definite shape and a definite volume. It won't move. If you drop a solid, it will be there, it will not move. You understand? Because of what? The force holding it is strong and is holding the particles firmly, so they won't move. And this force holding it gives it what? Shape, gives it volume. Remember also that the solid state has a fixed mass. It has a fixed mass because of what is the matter. It has a fixed mass. Then talking of the liquid state of matter, liquid state of matter is like an intermediate between the solid state and gaseous state. The particles in liquid state of matter are held by forces also, but the force that is holding it is not as strong. It's not The cohesive force is not as strong as the force that is holding solid state together. Is not as strong as that. So that's why to some extent liquid can move. For example, when you pour water on the floor, water is liquid. When you pour water on the floor, it can move to a certain point. And this makes, because of this movement of particle, this makes the kinetic energy to be ahead of solid state of matter. Then now talking of the gaseous state of matter. You ask yourself, is gas really a matter? Yes, gas is really a matter because it occupies space. Yeah, it occupies space. When you take a balloon and you put air into it, you see that the balloon tends to expand. It's expanding because of what? Air is occupying a space, and that air has a mass. You understand? So that because of that air is occupying a space, it becomes a matter. So there's gaseous state of matter do exist. So in gaseous state of matter, the kinetic energy is greatest because of what? Particles are always in random motion. And that is the reason when you spray perfume, you see that now person from a far distance to perceive the smell. Reason being that the particles within that gas are negligible. They are not The force holding it are negligible, so they move. The kinetic energy makes them to move faster to certain points, and people get what? To perceive the smell and tell you that I like your smell. You understand? So that is it about gaseous state of matter. So now there's a unique thing about this matter. The unique thing is the ability of this matter to change form. from one phase to another, from one phase to another. So I have this ice block, this ice block. So this ice block is solid. That is solid state of matter for water. So when water solidifies is ice now. So now ice is a solid, and it has the tendency of changing back to liquid, and from liquid to gaseous state. It can also change from gaseous state to liquid state, and from liquid state to solid state. So the reason for this change is just addition and subtraction of heat energy. Addition and subtraction of heat energy. For example, when you get a solid, let's just say ice block, and you subject it to heat energy. Subjecting it to heat energy means adding heat to it. It gets to a point where it will melt. It will melt, and if it melts, it turns back to what? To liquid. And if you still add more energy, more heat energy, it will change from that liquid state to what? To gaseous state. It will change from that liquid state to gaseous state. So that is it. Then it can also move when energy is removed. When heat energy is removed, it can move from that gaseous state back to liquid state, and from liquid state to what? To solid state. Okay, I already told you that what causes the change in state of matter is just addition and subtraction of heat energy. So when heat energy is added, something happens. When it is removed, another thing happens. I told you that this is just unique. So because of this, we are going to be discussing some terminologies. We are going to talk about melting. We are going to talk about melting. So what happens during melting? What happens during melting? Okay, melting occurs in solid states. Melting occurs in solid state. That's one thing you will know. So for melting to occur means that the solid has what? Acquired enough heat energy, which breaks the cohesive force that is holding the solid together. When it breaks it, it makes what? It makes the particles to disassociate, and when these particles get separated, they turn to liquid. That's what happens during melting. That's why if you bring your ice block and subject it to heat, it will turn to liquid. It will turn to liquid. That is it. That's what happened to melting. The thing that happened was that the heat energy broke the cohesive force that was holding what? The solid particles, and as it broke it, they had no other choice to become liquid. So this melting for you. And also we are going to talk about what vaporization means. Vaporization, when you hear about vaporization, one thing you should know is that it occurs at all temperature. But you know that temperature is directly proportional to heat. For example, if there is an increased heat, temperature will increase. If the heat is low, temperature will reduce. So as temperature is increasing, heat is also increasing. So for vaporization to occur at all temperature, which means that when heat is applied, temperature will be increased, and if temperature is increased, the rate of evaporation will also increase. That is it. The rate of vaporization will also increase. So now you ask yourself, what is vaporization? What is it like? What is vaporization? Okay, now vaporization occurs at all temperature. I've already said it. And vaporization just happens, or let me say vaporization is a phenomenon that occurs when the particles of liquid at the surface what gets enough kinetic energy to leave the surface of the liquid. So this vaporization is applicable in our daily life activities. For example, now if you wash a cloth, the cloth becomes wet, and you try to hang it outside for it to get dry, and you see that you still come back and see that the cloth has dried. Then what happens? You start to wonder. The thing that happened was that the wet cloth, the water in that wet cloth got vaporized. You understand? It got vaporized. It acquired kinetic energy that made it to leave that state, that made it to leave that liquid state in which it was in. So that is what happens during vaporization. So now we are going to talk about boiling. We are going to talk about boiling. Boiling is what we do every time. Some people boil water or boil other things. So now what happens? What makes water to boil? When you are boiling water, remember that you are adding heat, and because of you are adding heat, the rate of evaporation is going to increase tremendously. It's going to increase. Remember, we told you that evaporation occurs at all temperature, but when heat is applied, it occurs more. So now you are boiling water, you are adding heat, so the rate of evaporation will increase. So it gets to a point where the rate of evaporation, the evaporation becomes saturated, and when it becomes saturated and it meets the prevailing atmospheric pressure, boiling occurs. That's what happens during boiling. So the vapor pressure during boiling, when vapor is going out from, let me just say you are using a kettle, the vapor that is going out, it gets to a point that it becomes saturated in that environment, it becomes filled, then it tends to meet the prevailing atmospheric pressure, boiling occurs. So that's what happens during boiling. So we've talked of melting, we've talked of vaporization, and we've talked of boiling. So these three concepts happens because of what? Addition of heat. Now let's know what happens when heat is removed. So when heat is removed, what happens? So we are going to be discussing now condensation and freezing. Condensation and freezing. So when a gaseous state of matter, when heat is removed from gaseous state of matter, when heat is removed from a gaseous state of matter, we see that it's going to lose what? It's going to lose kinetic energy. It's going to lose kinetic energy, it's going to lose heat energy. And when it loses this heat energy, it becomes what? It falls back, gaseous state falls back to liquid. Gaseous state falls back to liquid. This falling back to liquid is what is referred as condensation. So condensation is a process by which the gaseous state of matter becomes liquid due to removal of heat. So when heat is removed, it becomes it becomes liquid, and this is what we call condensation. So when there's also continual heat removal, let me say now you've removed heat from gaseous state and it has become liquid state, and you continually also want to remove heat, or you've removed the heat again from that liquid state, it becomes what? Solid state. This is what happens. So now trying to explain it now with what happened with water, let me try to explain it. So let's just say that I'm boiling water, and the vapor that is in that is coming out from the water I'm boiling, I try to remove heat. You see that it's going to fall back to water. It's going to fall back to liquid, and from liquid, if I remove more heat from it, it will turn back to solid. Know that, remember that removing heat means adding colder body to it. It means it's going to become what? Become solid. So this is what happens during condensation and freezing.